In this topic, we are going to look at an introduction to vectors. A vector is a quantity with magnitude and direction, while a scalar is a quantity with only magnitude. An example of a vector is velocity, while an example of a scalar is speed. Displacement is a vector, and distance is a scalar. Weight is a vector, while mass is a scalar. Other examples of vectors are force and acceleration, and other examples of scalars are time and volume. Here we have a boat traveling from port A to port B at a bearings of 80 degrees. The distance between port A and port B is given to be 120 kilometers. Here we will go 80 degrees clockwise from the north, and this will give us the bearing, while 120 kilometers is the distance. In this case, we have both directions and magnitude. The direction being the bearing and the magnitude being the distance. We can represent a vector using a directed line segment AB. This directed line segment has a bearing of 80 and a magnitude of 120 kilometers. Let's look at other vector representation. We can represent vector using a directed line segment as shown previously, or we can represent vectors by using the letters A, B with an arrow on top, pointing to the right. This means that the vector will start from A and ends at B. When we write vector, we can also write it as a lowercase letter with a wavy lines below. For the typed version, it will be a bold lowercase a. Finally, we can also represent vector using a column vector x, y. Next, we shall learn how to find the magnitude of a vector. Here we have a vector PQ, and we are asked to find the magnitude of this vector. The two vertical lines here is the symbol for magnitude. The horizontal length here will be 5 units, while the vertical length here is 2 units. Therefore, we can apply Pythagoras theorem to find the magnitude of PQ, whereby x is 5 and y is 2. Simplifying, we will have 5.39 units rounded off to 3 significant figures. Next, we shall look at equal vectors. Two vectors are equal if they have the same magnitude and direction. It is important to note that the position of the vector does not matter. Is vector CD equals to vector EF? The magnitude of CD is equals to the square root of 3 square plus 2 square, which is equals to 3.61 units, while the magnitude of EF is equals to the square root of 4 square plus 1 square, which is equals to 4.12 units. Clearly, the magnitude and directions of the two vectors are not the same, therefore, they are not equal vectors. Is vector MN equals to vector OP? The magnitude of a vector MN is equals to 3 units, while the magnitude of vector OP is equals to 6 units. Although they have the same direction, which is pointing to the west, they are not equal vectors as they have different magnitude. Is vector RS equals to vector TU? The magnitude of vector RS is equals to square root of 2 square plus 2 square, which is 2.83 units, and the magnitude of vector TU is the same. However, you notice that the direction of vector RS is different from the direction of vector TU, and therefore they are not equal vectors as well. It is important to note that vector RS means that the vector will start from R and end at S, while the vector TU will start from T and end at U. Is vector RS equals to vector UT then? Yes, they have the same magnitude and the same direction. In summary, a vector is a quantity with both magnitude and direction, and the magnitude of vector AB is represented by two vertical lines, and we can find the magnitude using Pythagoras theorem, square root of x squared plus y squared. Finally, equal vectors are vectors that have the same magnitude and direction, and the position does not matter. And that's all for this topic.